We can also use a hypothesis test to compare the means of two groups. In this case, we have a sample of 40 males and 40 females and their weights. I'm going to claim that the mean weight of males is greater than the mean weight of females, which leads to a null hypothesis of the mean weight of males is less than the mean weight of females. In this case, because we have no information about the population variance or standard deviation, I am going to use a t-test. Now, I could compute this by hand. However, Excel has a nifty tool under the Data Analysis Tool Pack, found under the Data tab, that will allow me to compute this easily. I'm going to go to the Data Analysis tool, and I'm going to go down to a 2 sample assuming unequal variances and click OK. This leads me to several inputs. I need to input variable 1 and variable 2. It's common practice, and it will make your life a little bit easier, if you use the first variable listed, males, as variable 1. You may either highlight the entire column or just click on the column header B. That tells Excel to use the entire column. That makes variable 2 the females. And my hypothesized mean difference in this case is 0, because I'm not saying or specifying how much greater I think the males are than the females. I'm not saying 10 pounds heavier or 20 pounds heavier, just that they are heavier. So I'm going to enter in 0 because I don't have a specific quantity in mind. I would click on the Labels button because the first row is labels and I do not want Excel to include that, and then I'll go ahead and click OK. This output comes up on a new sheet, and there's several pieces of information. First off, we have some information about the males and the females, including their average, their variance, and how many observations of each gender there is. And it's important to note the number of observations for each group do not need to be identical. Excel went ahead and computed the test stat, or the t-value, the sample t-value for you, and it provides 2 critical values. One for a one-tailed test. Remember, that is if you have a less than or greater than in the hypothesis, which we do, and one for a two-tailed test. Notice we didn't have to tell Excel which kind of test we were doing, just what the actual data was. In this case, the test stat of 3.62 is greater than the critical value of 1.67. We do use the one tail because we had a specific case in mind. Therefore, we reject the null hypothesis and then conclude that the average weight of males is greater than the average weight of females, which probably isn't surprising. But I want to draw to your attention another way to make this decision, because we have what we call a p-value, or probability of type 1 error. And there's a great general rule that works for all hypothesis tests. If p is less than our alpha level, then we reject the null hypothesis. If p is greater than our alpha level, we accept the null hypothesis. This is great because we don't have to worry about positive or negative signs. We don't have to worry about how many tails we have for looking things up on a chart, although you do notice the p-values differ for the different tails of tests, but we don't have to worry about it reference table-wise. And the rule stays the same, whether we're doing a t-test, a z-test, a chi-square, or some test that we'll talk about in the future. The downside to the p-value is that we do need technology such as Excel to compute it for us. So there are some cases where Excel may not run that type of test and we can't use the p-value method. Well, let's take a look at what our p-value is. We are running a one-tailed test. We want to expand this a little bit more. We can see the p-value for one tail is 0.003. which is less than alpha. I didn't specify an alpha level right up front, but we'll go ahead and use 0.05. And we see that that is less than 0.05. Therefore, we reject the null hypothesis, which does agree with the decision made above, and they should always agree. One method will not lead to a different decision than the other. It's just a different way of making the decision. And conclude the average weight of males is greater than the average weight of females. So while you're welcome to use the critical value method, you now have a new method, the p-value method, to assist you in deciding which hypothesis is supported.